This is the walkthrough video for PCTC 2020-2021 round 2 question 10, making arrangements. So in this question we're given a string of letters and then we're given a number. And if we were to organize every permutation of the string of letters in alphabetical order, we want to print out that numbers of the string at that position of that number. So this question is a bit difficult, and the reason it's difficult is because, as you can see here, it tests algorithmic efficiency because n can be huge, and the length of the first input string could be up to 20 or up to 19. And so that means there are so many combinations, like there are this many combinations that it could ask us to check for. And so we can't just sit here and kind of calculate every permutation and then like add every permutation to a list and then extract the ith element of the list and print that off to the screen. Because finding out every single permutation is going to take a while, and then adding it to a list takes a while, and then storing such a huge list will probably not fit within the memory. And then we're going to have to actually go through the list to find the final answer. So lots of inefficiencies with that approach. So we're going to have to think of a better approach, a more algorithmic approach, one that uses maths, because maths is typically always going to be much faster than trying to just simulate something. And the reason maths is faster is because your maths expression is going to be basically just as long, no matter how big your input is. So even if you have a massive input, you might still have to do the same maths expression. I mean, yes, your numbers in your maths expression might be bigger, but realistically, that is nothing compared to the alternative, which is if your input's bigger, you're going to have to run like 10 different lines of Python code a million more times, versus doing maths with a slightly bigger number. So that's why maths is usually a better approach when it comes to efficiency. So what's the approach to this going to be? Well, we are going to so this is the example input, and the question wants us to get the 12th element, and these are all of the possible permutations that you can make from these 4 letters. So the way we're going to do this is we're going to start off with an empty string, which is going to be our answer string, and we're going to slowly build up our final answer by adding 1 letter at a time to our string. And the reason we're going to do that is because that allows us to essentially check how many possible permutations are there for the given letter. So essentially the problem is we want to build up our answer string of these 4 letters, but we want to make sure we get the right number. So like we want to make sure we get the 12th permutation. And the way we do that is we come up with a math expression to calculate all the possible permutations of the rest of the letters, assuming we chose one of the letters. So that's a bit confusing, but I'll kind of demonstrate it here visually. So at the beginning, our first choice or our first problem is to try and figure out what our first letter is going to be. And obviously in this case the answer is A, but how do we know that? How do we come across A? Well, if we look at all the possible permutations here, and there are actually only 12, I think. Yeah, there are only 12. But if we look at these permutations, we can essentially either select A, B, or C to be our first letter of our answer string. If we were to select A, we would be in this group. If we were to select B, we'd be in this group. And if we were to select C, we'd be in the rest. And so you can see at the start what letter we choose, then the letter we choose affects all the possible permutations that come next, right? So if we choose A at the beginning, we're now restricted to only that group of letters or that group of permutations. If we choose B or C to begin with, then we're only restricted to these groups. And so you can see, or maybe you're kind of beginning to see how we can use this to our advantage, because if we calculate the size of each group, then we can figure out which group we're in. So if our goal is to get the 12th string in this case, well, the first group is size 6, the second group is size 3, and the third group is size 3. And if you want the 12th, well, the 12th, as we know from the answer in the example, is that one. So we want that one. And the reason, or the way we can extract that one and figure out we want that one, is by saying, well, if we choose an A as our first letter, we only have 6 possible permutations. But I want the 12th permutation, so A definitely can't be our first letter. If we choose B as our next letter, then I have 3 permutations. So in total, I've gone through 9 permutations. I've gone through all of the A's and all of the B's. But 9 is still less than 12. I want the 12th. And so we have to choose C, because if we choose C, we get the next 3 permutations. So we've already got the 9 from the A that we kind of discarded. We've already got the 3 from the B that we've also discarded. And now we're getting the 3 from the C. And that would get us 12. And yes, 12 is within 12. So 12 is within this group, which is if we were to choose C. So let's do another example. Let's say instead of 12, we want 7. Okay, so what do? We look at the first group. If we were to select an A, we'd get the permutations from 1 to 6. Well, I want the 7th permutation, so let's not select A. If we were to select B, we get the permutations not from 1 to 6, but from 7 to 9. The next 3 permutations. So you get the permutations from 7 to 9. And in this case, 7 to 9 does capture the number that we want, which is 7. And so we'd select B to be our first letter. And so you can kind of see what I'm doing here, which is that we're figuring out, depending on each letter we choose, what group of permutations do we have access to, right? Because by selecting A, for example, we lose access to all of these permutations. Like, none of these will ever be possible if we start with an A, because none of those start with an A. And so we just need to kind of figure out which group our desired number lies in. And then we can just repeat this process for every single letter, right? So we figured out, in this case, we wanted A to begin with. Then we can repeat that again. So now we're restricted in... No, sorry, that's all. Ignore that, sorry. So we figured out that if our target is 12, we want a C to begin with. Because that group captures 9, 10. That group captures 10, 11, and 12. Okay, so now we're within that group. Now what do we choose? We could either choose an A or a B, because we've already used the C up, so let's cross the C out. So we can either choose an A or a B. Well, if we choose an A, then we're restricted to those 2, and if we choose a B, we're restricted to that one. And so, again, we've got another 2 groups. This is a group of 2, and that's a group of 1. So how do we figure out which one we want? Well, at this point, this is where we have to begin chopping down our 12 number, right? Because essentially, like, 12 doesn't lie in the numbers 1 to 3, and there are only 3 options in this group. So clearly, like, we need to do something to make this more manageable. And what we do is we take away all of the permutations that we've skipped. So we've skipped all of the A's, that's 6 of them. And we've skipped all of the B's, and that's 3 of them. And so our target is now going to be equal to 3, because it's 12 minus 9, so 3. And so our new target is 3. And that allows us to use that 3 whilst repeating the algorithm for this group. And so if our target is 3, what letter do we want next? Do we want A or do we want B? Well, we want B because A only captures 1 and 2, whereas B captures 3. So let's put a B. And obviously at this point, we now kind of don't really have any more letters to choose from. Like, we have to choose A, and then we have our answer. Okay, so let's try this example let's try doing this by hand with another example, and let's go back to 7 from earlier. So if our target is 7, what's our first letter going to be? Well, it's definitely not in the 6th group, so it can't be A. And so we should shift 7 to kind of account for the fact that we're now skipping past all of the A's. So we should do 7 minus 6, because there are 6 in that group that we're skipping past. That's going to be equal to 1. So our new target is 1. Okay, so does 3 lie with... So does 1 lie within the range 1 to 3? Yes, it does. And therefore our first letter is B. Awesome. Now we've got rid of it. We got rid of a B. Now what? Now we need to figure out whether our next letter is an A or a C. So an A captures the first 2, and a C captures the next 1. Well, our target is 1, and so we want one of the first 2 ones, and so we want to put an A. And so we've gotten rid of an A, and we got rid of that. And because we chose the first one, we don't need to adjust 1, right? Because we only adjust our target if we've skipped past possible permutations. In this case, we haven't skipped past them because we've chosen the first group. We've chosen the group where you begin with A after you've chosen a B. So BA is our first group. You only have to adjust your target if you decide to skip a whole lot of permutations, like we did up here when you skipped all of the permutations beginning with A. Okay, so now what we do, we have B and A. Now we can either choose from A or C. Well, if you choose from A, that group encompasses 1, and C encompasses the next one. and we want the first one because our target is 1. And so we want to choose the first one, which is A. And of course, we're only now left with one letter to choose from, so that's going to be C. And awesome. Now I'm going to run through one final example. I'm going to do this very quickly, so take your time and pause if you still don't get it. So let's just erase all of that. So I'm going to just choose. I'm going to choose the number 5. So our target is 5. What's our first letter going to be? Well, it's captured within the first group, so it's going to be A. And since we haven't skipped any, we keep 5 as our target. Now within A, what groups do we have? We have another A, we have another B, and then we have a C. And that's group of size 2, 2, and 2. Well, 5 does not lie in the first group. So, oops. Let's first get rid of that. So 5 does not lie in the first group, and so we can get rid of that first group. And we're going to skip past that group. If you skip past that group, remember, we have to adjust our target. So let's turn that into a 3. So now our new target is 3. Does 3 lie in the next group of 2? Well, no. 3 is bigger than 2, and so the next group of 2 does not encapsulate the target element that we want. And so we can also skip past that group, and therefore do another -2. And then our new target is now going to be 1. Now, the final group that we're in is AC. And does AC capture our number? Yes, because AC has 2 elements in it, whereas we want element number 1. So yes, C is our next number. Now what do we do? Well, there are 2 options. We can either choose B or A next. And while since the target is number 1, we want to choose the first one, so that's A. So let's choose A, and then obviously there's only one answer left, so we can choose B. And that is the process that we're going to be using to solve this question. Okay, so let's first take in our inputs. So that's going to be letters, and then target. And I would like letters as a list, and we'll see why later. So let's convert that to a list straight away. Well, actually, we see why now, because if you saw, as we were doing this by hand, we were crossing off the letters as we had used them. And so you can't really do that if you have a string. So we need a list to store our letters so we can cross them off or remove them as we've used them. And we also need to create our answer, our empty answer string in the solution. So now what do? We want to start building up this string. So let's have a while loop that continues running for as long as letters has elements in it. So what this condition checks for is whether there's any element in this list called letters. So for as long as there are elements in this list, we're going to keep running this while loop. And as soon as there are no more elements left, no more letters left over, we're going to end the while loop, which is what we want, right? But once we've crossed off all 4 of these letters, we want to end the while loop because we've got our answer. So for every pass, for every time that we want to add a new letter to our answer string, what do we have to do? Well, we have to first go through all of the possible letters that we could choose from. Like here you can see we could either choose an A, we could choose a B, or we could choose a C. So, what are the possible letters that we could go through? Well, I would say it is just the list letters, but remember, the list could contain duplicates. Like this contained a duplicate A, it contained 2 A's. So we need to make sure it contains no duplicates. To get rid of the duplicates in Python, we have to do set. But now the issue is, sets are unordered. And so this could be like, the set could be equal to like BCA or BAC or something like that. Whereas we want our set to be ordered alphabetically. We want to check A first, then we want to check B, then we want to check C. We want to check it in order. So we have to convert it back into a list to make sure that we can order it. And so once it's a list, then we can sort it by just doing .sort. And actually that may not work. We have to do sorted this way. Yeah. And so once we've got our sorted list of unique letters in our letters list, then we can iterate through this list. And so let's do that. So we can do for letter in this, we want to check to see if this letter is valid. How do we know if it's valid? Well, we first need to calculate how many possible permutations are in that group. And this is where I think you, or most people would learn this in year 7 or year 8. How do you calculate in maths, year 7 or year 8 maths? The question is, how do you calculate how many permutations there are of a given string? So how many permutations are there of, let's say, Bob? How many permutations are there of Bob? Well, the way you do this, and I'm going to rush through this because you kind of either know this or you don't, and if you don't, then I'm telling you, this is the case. So you count how many letters there are. There are 3 letters in total, and so there are 3 factorial permutations. Except that there's a repeat, right? B is repeated twice, and so we don't want to double count all of the times. Like Bob is equal to the same as Bob, because B is double counted twice. Whereas 3 factorial does not account for the fact that B is repeated, because like this might be the first B, and this might be the second B, so they're switched around. But equally, like they're the same string. We don't care. So we then have to calculate how many repeats are there of every letter. So there's 1 repeat of 1. There's 2 repeats of B. Sorry, there's 1 repeat of... Sorry, there are no repeats of O, so that the count of O is 1, and there's 1 repeat of B, so the count of B is 2. And then you want to take all of those. So if there are more letters, you continue counting how many of each letter there are, and you factorial all of them and multiply them together, and then you divide your 3 factorial with that. And this is the formula that we're going to use to calculate how many permutations there are. But what do we want to calculate the permutations of? Well, if you go back to this, then you can see that we don't want to calculate the permutation of all 4 letters, right? There are 12 permutations. There are all of these for all 4 letters. We want to calculate the permutations for if we chose A as our first letter. What are the permutations of the next 3 letters? How many permutations are there of the next 3 letters? Assuming we choose A. So we're making the assumption that we choose A, and then we're going to figure out how many permutations are there assuming we chose A, and that will give us the size of this group. So we can say, well, the first thing we should do is we should remove letter from letters. So let's do letters.remove letter, and this will just get rid of that letter. So it basically means that letters is now a list containing all of the next letters. And I should also just point out that even if there are duplicates in our letters list, like if there are 2 A's and we do letters.remove A, it's only going to remove 1 of the A's. So remove only ever removes the first occurrence of the element that you want to remove. So we don't have to worry about it removing a ton of A's. So now we can. So now that we have the next 3 letters, which in this case is A, B, and C, we want to run this formula. So this is where you can kind of get a bit efficient. If you know how Python works, you can import a few commands and be really efficient here. So the commands we're going to import, let's put that right at the top of our code. So from maths, I want to import, sorry, math because it's American. From math, I want to import 2 commands. I want to import prod and factorial. Factorial just calculates the factorial of a number. Prod will take a list and calculate if you were to multiply all of the elements in the list together. So you know how the command sum adds all the elements in a list, the default command sum? Well, prod does the same thing, but instead of adding, it multiplies them all together. And the next thing I want to import is from the library called collections, I want to import counter. And counter, actually, let's just Google this. So in Python, if we, let's see. Yeah, so if you look at this example here, open a new tab, you can see that we run counter on this very final line at the bottom is what we're interested in. We run counter on char list, and counter will spit out a dictionary where each key is the item in the list, and the value is the amount of times that item appears in the list. So you see here it says B3. That means B appears 3 times in char list up here, and it does. There's B there. There's B there. There's B there, and there's B there. So that's what counter does. We're going to use that. Okay, so now let's do our calculation. So that's going to be 3 factorial. So that's going to be len letters factorial. So let's do factorial len of letters. And then all of that divided by this bottom bit. What is this bottom bit? Well, we first need to calculate. We need to go through. So we first need to actually calculate the counter. So what is the counter of letters? Well, it's going to be this. And now we want to go through every value of that. So for frequency in counter letters dot values, so we're only going through the values. So we're only going through the frequencies of each of our letters. And for each of them, what are we doing? Well, we want to calculate the factorial of that letter. So we can do factorial, sorry, the factorial of that letter's frequency. So we can do factorial fric, like that. And this will allow, basically just give us like a list that contains the value of 1 factorial and the value of 2 factorial and so on, according to our input. But as we said, we want to multiply all of these together. And so the final thing we should do is just prod all of that. So this is a very long line of code, just because I've done this entire expression all on one single line. Hopefully it made sense as I built it up. And if it doesn't, you can kind of just implement this on multiple lines or in for loops and stuff. But I think this is just a neater way of doing it. That's going to be our permutations. So let's just call it perms. Or the number of perms, I guess. So n perms. So like number of permutations. Okay, now what do we want to do? We want to check to see, if you go back to our example, we wanted to check to see if the number of permutations is bigger or smaller than our target. And if it's smaller, that's good. No, sorry, if it's bigger, that's good. Because it means that's the group that we want. So we're going to say, if n perms is bigger than or equal to target, then that's good, because that group contains the final answer that we're looking for. And so what we can do is we can, to our answer string, we can add the letter that we removed from earlier, the letter that we assumed we're going to add, because that is indeed the correct letter. And that, remember, we have to leave target alone at this point as well, because we haven't skipped any permutation, so we don't change target. But what we do is we break out of this for loop, because we found our letter, so we break out of this for loop and repeat the whole while loop again. But what if n perms isn't bigger than target? What do we do then? Well, we need to remember we need to change targets. We need to decrease target by the amount of permutations that existed. So we can do target is equal to itself minus the amount of permutations that existed, and that will just kind of recalibrate target, as we saw what we did here, to like a more useful value of target. And of course, remember that on line 12 we removed the letter because we assumed that this letter is going to be correct, and then we did the maths on the letters list. But this letter was clearly not correct, so we need to re-add the letter to the letters list. So letters.append list letter. So we're just re-adding that. Now, you might ask me, like, you might question, why on earth did we remove the letter if you kind of have to bother adding it again and deal with all of this extra nonsense? The reason we did that is because it makes doing this way faster. Because if you remember, it means that we could just take len of letters, because letters has the correct number of letters in it. We can also just do this, because again, all of these values are going to be correct if we make the assumption that letter is the next letter. So by removing letter from our letters list, it makes the calculation on line 12 much easier. But of course, you can figure out a way to do this without having to remove letter. I just think this is faster. And this is actually pretty much our code done. All we need to do is print answer, because our code will just come like basically just keep repeating this for loop in the while loop until we run out of letters to continue adding to our answer string. And so that gets a 10 out of 10 without going over the time limit of 3 seconds and the memory limit of 10 megabytes. So that was a very algorithmic question. I quite enjoyed that, to be honest. And hopefully it made sense. If it doesn't, it is a tough question. It is very tough, actually. The logic of this is quite tough to understand. So, copy the code, take time to understand how this works, because it can be quite a powerful concept.